There's this invisible force all around us, all the time, that decides whether we feel hot or cold. It's called infrared radiation. And once you understand how it works, so many things in our everyday lives just suddenly make sense. So let's dive in and uncover this hidden world of heat. We're going to kick things off with a really simple question, something you've almost definitely experienced yourself, even if you never really stopped to think about the physics behind it. I mean, seriously, think about it. It's the same sun, the same you, the same day. So, what gives? Why the huge difference? It's a simple question, but the answer opens up a whole world of fascinating science. And yeah, this is exactly what it feels like, right? The black shirt is just baking you, while the white one feels so much more comfortable. But this isn't just in your head. It's a real physical thing we can actually measure and explain. And that is the key to this whole thing. Both shirts are getting blasted with the same energy from the sun, but they deal with that invisible heat, that infrared radiation, in totally different ways. So to really see what's going on, let's run a couple of quick virtual experiments. Okay, first up, the great heat giveaway. We're going to figure out which kinds of surfaces are better at, well, giving their heat away. Think of it like a race to see which one can cool down the fastest. So, here's our setup. It's super simple. 2 cans, totally identical, same amount of hot water in each. The only thing we're changing is the outside surface. One is a matte black, the other is shiny silver. This way we know it's a completely fair test. All right, it's prediction time. Before we see what happens, what does your gut tell you? Which of these cans is going to win the race to cool down? The shiny one or the black one? Lock in your answer. And boom, the results are in. And wow, it's not even close, is it? The black can's temperature just plummeted compared to the shiny one. This tells us loud and clear that the matte black surface is way, way better at radiating heat away. So this brings us to our first big idea, a key term, emitter. An emitter is simply an object that radiates or gives off thermal energy. And our little experiment just proved, without a doubt, that matte black surfaces are fantastic emitters. Shiny ones, not so much. Okay, so let's get our findings down. We know for sure that matte black is a good emitter and shiny silver is a poor one. But hang on, look at that last column, absorber rating. See those question marks? It makes you wonder, doesn't it? Is there a connection? If you're good at giving off heat, does that mean you're also good at taking it in? Well, there's only one way to find out. All right, time for round 2. This time we're flipping the whole question on its head. Instead of seeing which surface loses heat the fastest, we're going to see which one gains it the fastest. The setup here is just as straightforward and fair. 2 identical plates, one black, one shiny. We'll stick a thermometer on the back of each and put them the exact same distance from a heat lamp. Then we just watch what happens. Okay, let's do this one more time. Make your prediction. This time we want to know which one heats up the quickest. Is it the shiny plate or the black plate? What do you think? Whoa, and there you have it. This result is even more dramatic than the first one. The black plate's temperature just shoots through the roof. It's absorbing that heat like a sponge. Meanwhile, the shiny plate is reflecting most of that energy away and barely warms up in comparison. And that gives us our second key term, absorber. And here it is, the big reveal, the crucial connection. The best emitters are also the best absorbers. If a surface is good at giving off heat, it's also amazing at soaking it in. And that is exactly why you feel so incredibly hot in that black t-shirt on a sunny day. So we've totally nailed down that the surface type, black versus shiny, is absolutely critical. But is that it? Is that the whole story? Turns out, not quite. There are a couple of other major factors that control how fast heat gets transferred. Right, that's the perfect way to put it. While color and texture are a huge piece of the puzzle, they aren't the only pieces on the board when it comes to how quickly something heats up or cools down. In fact, there are 2 other fundamental rules of radiation that are just as important to understand, and they have everything to do with temperature and, well, size. First up, surface temperature. Now this one is pretty intuitive when you think about it. The bigger the temperature gap between an object and its environment, the faster the heat radiates away. A super hot mug of coffee is going to cool down way faster in a chilly room than it will in a warm one, right? That heat is just more desperate to escape. And the second big rule is surface area. You can think of this like an object having more doors and windows to let heat in or out. A big flat radiator in a house has a massive surface area, which is what allows it to efficiently dump heat into the room. A small, compact little ball with the same amount of heat inside would cool down much, much more slowly. Okay, so now we have the complete rulebook: surface type, temperature difference, and surface area. Now for the fun part. Let's see how these simple principles are used in some seriously clever ways all around us in the real world. And this is where it all clicks into place because you start seeing this stuff everywhere. Those cooling fins on a motorcycle engine, that's all about maximizing surface area to get rid of heat fast. That shiny silver lining inside a thermos, that's a pore emitter and a pore absorber, designed to trap heat in your coffee or keep the cold in your water. Black solar panels are made to be amazing absorbers, while white painted houses in hot countries are the exact opposite. And what about those emergency space blankets? The physics here is just incredible. That ultra-thin, shiny layer is such a terrible emitter that it reflects about 95% of your own body heat right back at you. It's literally keeping you warm with your own energy. Which brings us to one last thought, a little brain teaser to leave you with. We know the shiny surface is a pore emitter, which is why it keeps you warm. But remember our experiment? It's also a really poor absorber. So with that in mind, how could that exact same blanket be used to keep something or someone cool? Think about the rules we've covered. The answer is hiding right there in the physics. Thanks for joining me.